Hi. Today I'm going to talk about measuring benefits. So when we're looking at a benefit cost analysis, we need to weigh the benefits against the costs. We talked a little bit about how we put that together and what we make of it at the end, but we haven't really talked about how we actually measure benefits. So the benefits of most environmental regulations or environmental policies are that we have higher environmental quality. So a program that would reduce air pollution will make the air cleaner. And the big benefit of that is that cleaner air means we end up with healthier people, because pollutants in the air cause asthma, they cause cancer, they cause all kinds of breathing problems. And so we end up having people who die earlier because of air pollution. So preventing air pollution, the big benefit is that people are living longer. People are living healthier lives. They're having less sickness. So we call it mortality when someone dies. We call it morbidity when someone is sick. So the main benefits of environmental regulations come in the form of improved human health, lowering mortality and morbidity. So how do we put dollar signs on that? That's the tricky part, because if we're weighing the benefits against the costs are in dollars. We need the benefits to be in dollars as well. So putting dollar signs on how much people value their life is a controversial thing. At first blush, it sounds like we're trying to pin a dollar value on a particular person, but that's not actually what we're doing at all. What we're doing is we're looking at small changes in risk, in probability of death. And we're looking at how much people would be willing to pay to have a small increase in their safety, to lower the probability of death a little bit. Or we could look at how much people have to be compensated to have a small increase in the amount of probability of death. So where do we see those kind of decisions? They're actually all around us every day. We all take risks. When we get behind the wheel of a car and drive, we're taking a risk. There's a chance that we could die in a car accident. If we smoke a cigarette, that's definitely taking a risk, right? If we have an alcoholic drink, even if we have a sugary non-alcoholic drink, these things all carry risks with them. And the probability of dying from drinking a Coca-Cola is really, really small, right? But all of the things we do are associated with these small changes in the risk of death or morbidity, having some sort of health issue. So we can look at the decisions people make on an everyday basis and get some sense of how much value they place on these small changes in risk. Where do we see this? In the marketplace, two main places. One, when we have workers who have some sort of risk affiliated with their job. So if we have two workers who are in chemical factories, and one works with a hazardous chemical. The second worker has the same job. They're stirring a big vat of chemicals. The second worker does the same thing, but the chemical that she works with is benign. It's not hazardous. So those are two very similar jobs. They're doing the exact same sort of task. The difference is one job is riskier than the other, right? One is handling a hazardous material, the other one is handling a benign material. So the question is, how much would we have to pay someone to work in the hazardous job instead of the safer job? Again, it's a small change in probability of death that we're talking about. Most workplaces these days are relatively safe, but there are differences in how risky jobs are. And when we look at what people are paid, we see that there is a premium paid to people who are willing to work in risky jobs. So by looking at that premium, that actually tells us how much at least this type of worker values a small change in their safety. We can apply that same sort of value to a change in safety that comes with improved air quality from an environmental regulation. Now, the units we usually use are something called a value of statistical life, a VSL. So VSL is taking a small change in probability and the premium that people put on being a little bit safer and kind of multiplies it out over a population so that we have one saved life in probability. We're not saying that a particular individual is saved, and that's why we're not pinning a dollar sign on a person and saying they're worth this. Instead, we're saying, well, generally, these people need $100 extra to do this task that has a risk of death of 1 in 100,000. If a lot of people are willing to pay about that much, $100 for that sort of risk, we can multiply it out and come up with a number. Well, saving a life with that willingness to pay, 100,000 times $100 gives us $10 million. So $10 million would be the value of statistical life in that scenario. Now, it turns out 10 million is about what a lot of the current estimates are for what workers do need to be paid to work, what that premium associated with changes in risk is. Now, we also have estimates coming from the housing market. So how much are people willing to pay for a house that's identical to another house, except the first one is close to some pollution that is known to carry some, say, risk of cancer. So maybe it's downwind of a factory that emits stuff from its smokestack. Now, I would guess that almost all of us could agree we would rather live in the house with clean air, right? So we would be willing to pay more to buy the house with clean air. We say that the environmental quality is capitalized into the property values. We're going to pay more for the house with better environmental quality. If we look at real estate markets and we look at places that have differences in air quality, in being close to, say, Superfund sites with contaminated soil or perhaps water pollution, and when those pollutants are associated with a risk of mortality, we can come up with a VSL measure by looking at that. How much more are people willing to pay for the house in the cleaner neighborhood? And again, in the housing market, we end up with a wider range of estimates, but the VSL that comes out of that is usually something in the $2 to $20 million range. So I often think of a VSL of around $10 million in today's 2019 dollars as being kind of the best estimate based on people's behavior when we look out at the market. And so those aren't the only benefits we get from environmental regulation. We also improve, say, wildlife habitat, or we get to swim and fish in cleaner water. And those are things that we enjoy and that we place values on. So those are benefits of cleaner environment as well. But the main driver of benefits for most environmental regulations is the improvements to human health and life. And so the value of statistical life is measuring the value we place on staying alive. And we can also do a similar thing to see what people are willing to pay to avoid getting sick with, say, chronic bronchitis or asthma or COPD and different diseases. And that gives us another measure of the benefit of improvements in something like air quality. Thanks.